course, overall topic is concrete under pressure, mastering resilience in extreme environment. So repair and maintenance in hostile climate, it actually gets linked to what just Mr. Pandit talked about, right? So see, the materials which you produce with the expense of energy, right? Concrete, steel, etc., they would like to dissipate that energy. That's the nature's way. Thermodynamics would tell you that. So they would have a tendency to actually dissipate that energy. So you cannot control that tendency. So you produce cement with the expense of energy, cement will react and dissipate that energy. Chemical reaction, chemical potential becomes high. Steel, which is not a natural material again, it is actually an oxide or pyrite, whatever it is. So, but you can control the rate. So if you can control the rate, like just now you were saying about coating, fusion bonded, epoxy coated and all. So you're creating a layer to control the rate. So you can control the rate, but not the tendency. So our aim generally is control the rate, and kinetics can be controlled. That's what we see. So concrete, steel, plastic, etc. are not maintenance free, produced at the expense of energy. And that gets linked to the durability automatically, because all of them degrade with time. The material degrades with time. And it's quantified through service life for elements. You see, people are confused about the life. Somebody will say life of concrete structure is 100. Does it mean that concrete will die after 100 years? These are inanimate objects, and their life is contextual. Depends upon the context. All theaters in Delhi, Mumbai, many of them got converted into shopping malls. So their loads have changed, functional performance changed. So it's a functional life. Some you think, for example, many of this, I visited, I think, one of some mills in Mumbai. I stayed close to there. So there were a number of textile mills which got closed, and then they were converted into, that area was demolished and converted into apartments because real estate prices were higher. So the life of those buildings, even though they could have been longer, but economic life, forever, whatever best known. Physical life can be infinity if you maintain them. Archaeological Survey of India does that. So therefore, life, when we talk of service life, we always refer to the elements. Because structurally also we design elements-wise. First find out the forces in the elements, and then find out how much resistance it can have, and then overall scenario. So service life of elements in the context of concrete, or even in case of steel, really, steel members, that is what it is. So it degrades with time and reaches a serviceability limit. For example, appearance of first cracks, etc., that's what we call service. Now, since it's a short presentation, let me quickly go to, because I believe that concrete is, as we would understand earlier, I would not call it concrete today, I'll call it concrete composite. It was a composite even earlier, but then people will refer only to concrete. And concrete composite, actually it is a four-dimensional space where you can represent it. You will have a binder in x-axis, kind of fiber reinforcement. I'm talking of material, not the reinforcement, rebars. I'm not talking of rebars. It is fiber reinforcement, like, he was talking of concrete that can withstand, high strength concrete that can withstand about 1200 degrees centigrade or something of that kind. You have to put actually polypropylene fiber, which will melt and allow the moisture to go away, evaporate. Otherwise, it would crack. So that's been seen. Fire resistance of high strength concrete is relatively poor, but they put polypropylene fiber. So fibers are the part of the material system. Steel fibers, like in pavement concrete, you put hybrid fiber system. So fibers are there. And then you have got the matrix, which can be aggregates of different, bulk of it. So it could be 600 micron in reactive powder concrete to 150 mm in concrete, like dam concrete, mass concrete, roller compacted concrete also. Then you have got additive. So this is the fourth dimension, additives of varieties of kind. So concrete actually today is four-dimensional, at least, if not more. That's what I think. And its performance is also four-dimensional. It's very versatile. So what are the four dimension? One is the fresh state performance, like self-compacting concrete. From zero slump roller compacted concrete to self-compacting concrete, which does not require any compaction. You talk in terms of minimum slump flow and things like that. Then you have got a strength performance, safety related, load carrying capacity. So capacity more than the resistance. Then you have got long-term performance in terms of what you call, so-called, we are calling durability and so on. And sustainability is the fourth dimension which has come over the last 10, 15, or maybe 20 years. So it's also a four-dimensional one. And versatile concrete system, composite system can be designed for the requirement. If it is to be designed for highway, you have to specify these are my requirement, but then materials must be available and so on and so forth. So design according to the requirement. So concrete composite, it can take care. So maintenance repair also it can take care. Now, if you look at service life and repair, because I'm talking more of repair, if you use a material which will go to the serviceability limit, acceptable, not exactly total serviceability limit, but somewhere at the acceptable level, you start repairing it. And again, you repair, and again, you will repair, and again, repair. Extremely costly it will become, because there's something called disruption cost also. So repeat the same material, again, same material. So that many times you are using the same material again and again. And therefore, generally it is seen for many cases, particularly rebar corrosion, let's say even in marine environment, if it is good concrete made, somewhat good concrete made, it will not show anything in the beginning. That's called initiation period. But after that, once it starts active deterioration, then you may have to repeat it. But if you are repairing it, repair has to be done in such a manner that it goes up to the end of intended design life. Now, intended design life is, the structural engineers use this, 50 years return period of the wind, or earthquake that will come, or wind that will come once in 50 years, that will come once in 50 years. So that's intended life. So you should actually design the system maintenance free, at least for that period of time. Of course, monuments can be for 100 years, 500 years, 1,000 years, whatever. Now, coming to Indian scenario, this is important. We have actually, as I shall be talking a little bit more on it, although I don't think I've put a climatic climatic diagram of Indian map. We do not have, the condition is totally different than North America or Europe. Subtropical condition. While in India, it is tropical condition. Tropic of Cancer passing through Gujarat, Ahmedabad, somehow close to Ahmedabad to Agartala. So that there you have variation of climate variation, you have a dry summer in some places. So it depends upon latitude, and Himalayas makes a lot of difference for us. Himalayas causes monsoon. So you have intermittent scenario where deterioration occurs, because all the deterioration in concrete system or many of similar material is associated with the moisture, solution phase reaction. So you will have actually wetting and drying controls many of those conditions. So one can actually consider the exposure zone for service life prediction in India. Some of my friends, young friends and students, they are trying to bring something similar in IS code now, because this I have been presenting in many places. We must classify our exposure zones in two cases. One is a marine zone, another is a non-marine zone, continental zone you may call so, because we have a 7,000 kilometer long marine environment. And there the deterioration is very high, as has been said just a few minutes before. So there are also again three classes we can talk of. Submerged, all the time under water. Well, there the problem is relatively less compared to splash zone, where wave comes and hits. Wetting and drying occurs, and what you call tide, high tide, low tide, spring, and those kind of tide affects wetting and drying. And then offshore within 10 kilometers, you will have again problem because aerosol salt in air, aerosol formation occurs at the crest of the wave, and this can travel along the wind inside. Wind can bring it inside within 5-10 kilometers, and you can have problems. So that's marine zone, I'll call it. Non-marine zone will go with our climate, hot, dry, desert climate. That's in most of the Rajasthan and part of the Gujarat. Hot, dry, desert climate. You have very little rainfall there. Temperature can go as high as 50 degrees centigrade. Very low humidity in summer, and you have a dry winter. Then you have warm humid climate, as we call it. All the coastal areas, northeast, high rainfall, so longer humid scenario, right? And then composite monsoon climate is composite. So it has both of these components, and that's the largest part of central India. Mumbai will fall in warm humid climate. Delhi falls in composite monsoon climate. And there are some very high precipitation zone where rainfall is very high. So this classification, exposure zone classification for service life modeling, is what I have been suggesting because it's India specific. European condition you can't take. You can't take North American condition. They have other problem. North America and Europe has the problem of de-icing salt. The corrosion has been occurring in their flyovers and such other places because they have snowfall, and to melt the snow, they use sodium chloride is the cheapest salt. So de-icing salt you put in, the freezing point depression occurs, so automatically easily you can remove the snow, and that has been their cause. But our Indian scenario, it is different. We have problem related to weather. So therefore the question is, this is the scenario. You actually should be doing maintenance, but before that you should actually doing inspection regularly. Then you will save the maintenance cost. And what are the factors which affect the condition of the structure? Obviously, quality is definitely important. Environmental conditions. So as I was saying, Indian environmental conditions, they are pretty important because they vary. I've said 6 exposure classification one can think about. And then loading is important because where you have got cyclic loading, reversal of stresses, cracks can come. Although isolated cracks do not cause much durability problem or maintenance problem, but fatigue, reversal of stresses, that can result in all sorts of problems. Now look at splash zone, you have reversal of stresses and wetting drying reversal. But bridges, let's say bridges in the coastal area, if you travel from Mumbai to, let's say, the Western Highway that goes on Goa and then to Karnataka, what do you call, the Kannada district, North and South Kannada district to Kerala. You every 10-15 kilometers you cross a bridge. Sometimes you will come across tunnels also. Konkan Railway does that. Now all these bridges are actually, their piers, they will be in contact with marine water, backwater or something of that kind, rivers. Even 25 kilometers in Gujarat, I personally seen such, involved in a project where the saline water comes within 25 kilometers from the. So that is, and if you have bridge, then you have got reversal of stresses. So both effects. So what you should do, exposure condition should take care of both environmental condition and loading. Environment, you can classify it, well, IS 456 does, but I am not bothered about that because that's a prescriptive, for requirement which they copied from British Code 8110. But I think one should look into Indian scenario and classify, and not only prescriptive, theoretical modeling can be done. You can design for service. Anyway, you can classify the environment as aggressive and non-aggressive, and loading as static and fatigue, and think of very severe condition, which is aggressive environment like marine environment, wetting and drying, and you have got reversal of stresses. Like I said, bridge on Sarabati River. I think Sarabati River is one of those rivers just going to the sea. They are in the western coast or very close to the seashore. So that's the condition. Or aggressive environment with static loading and non-aggressive environment with cyclic loading. So that exposure condition you can call severe, And normal is neither aggressive nor really cyclic loading you have. Building, you have got quasi-static load. Imposed load is quasi-static. It is not reversal of stresses. Quasi-reversal, you can say. It comes, furniture, people come and go. That's very small load. But bridges really there. So importance of structures, you can think of very class 1, class 2, class 3. Class 1 is very important. And therefore, maintenance inspection interval could be something of this kind. This is suggested in FIP, right? Comité d'International Béton. They're now part of FIP, Federation d'International Béton. And that's a good criteria. In a very severe condition, every 2 years you should inspect them. Once, in fact, every 1 year. Once you should do visually, others sometimes with some instrument. So these guidelines are available, but you can model them also. Repair cost will increase if you don't delay the repair. So therefore, it increases in a non-linear manner. So inspection will save your repair cost, and you should find out total cost, and you can find out what is the optimal time of your inspection. And correspondingly, you do inspection, repair cost will reduce. And one can model this, a small equation, but I don't think I'm going to equation. But one can look into life cycle cost, which will include maintenance cost, right? If you spend more initial cost, more cost on quality, and longer service life, then your maintenance cost will be less. So last few slides, marine environment splash zone we are talking of. This is the scenario. Wave, 2 waves, you can actually superimpose them. And then versatile modern concrete can take care of this. We did modeling. We have actually estimated service life and things like that for marine environment or otherwise in different 5, 6 coastal locations we have taken, and cover required for different concrete. I mean, this is a nascent stage. One has to do a lot of experiments. In future, we have started this. A lot of our publications are there. This was my 33rd or 34th PhD student actually who did this. And these are the stations we looked at. We also looked into scenario of in continental one and 5 stations we took. One is Chennai, which is warm humid, Delhi composite monsoon, Jodhpur wet and dry. These slides I have not presented, not even copied. And you can even model the cracking of concrete to fracture. So I'm not going to this anymore. But last, I'd like to do coating and surface. He just mentioned galvanized iron and so on. Better steels are available. Japanese have got much better stainless steel. And then people are trying to use cathodic protection. I'm not very sure about their performance in terms of buildings. But in bridges or marine structure, they can use. Waterproofing, very important. Health checkup regularly, repair, rehabilitation, that's very much required. And last, I want to tell you the corrosion monitoring we have been doing. In fact, I fabricated equipment when nothing was available in 1995. My first student, Professor Shamshad Ahmad in King Fahd University, is now very senior professor. So, but what I wanted to emphasize is that you can put in these sensors, embedded sensors are now available, which can measure the corrosion rate. And you put that in concrete, particularly things like splash zone and so on. And, concrete has evolved in this manner, right, over the years. And you can use now IoT. For example, these sensors can send you signal. And, this can also learn through machine learning. So this will send the signal that what is the current scenario. For example, Hafsel potential, which is one of the measures for corrosion tendency, even corrosion rate, and then maybe activate a cathodic protection system in future. Just I want to say that. So smart, real time, it is possible. This is for building management system. This can go into infrastructure management system, artificial intelligence. So you embed sensors into the structure, not everywhere. The cost involved is there. So you put in such structures, let's say bridges there in the western coast, eastern coast, or wherever it is, and then embed them, and they'll send signal. They'll send signal to the cloud. Cloud will react, and then possibly can start an impressed current system. So I think that's all I wanted to talk about, right? So that's it. Thank you.